All right, worksheet 6.3, AP problems. We have a few multiple choice here. Number one says that the graph of a slope field this is a graph of the slope field of which of the following differential equations. So when you look at this, there's a couple different ways you can go at it. You notice that going along here, when x equals 1, we have 0 slopes going here, right? So anytime x equals 1, I should be able to get a 0 slope. So if I kind of look at my options, if I put 1 in here, y would have to equal 2. And at 2 for sure it does equal 0, but everywhere else it might not equal that. If I put 1 in here, it doesn't have to equal 0. If I put 1 in here, it does. This would be 0 for sure, and this one would be 0 for sure. So C and E kind of give me that option. But I also notice that I have horizontals going across here, and that's where y equals 2. So anytime I put 2 in for y, I should be able to get 0 as well. So again, putting 2 in for y here makes 0 when x is 1, but not when x is anything else. Doesn't make sense anywhere in here. If I put 2 in for y here, I don't have to equal 0, but I do right there. If I put 2 in for y, 2 minus 2 would make 0. So C is the one that happens to kind of comply with both of those ideas. So if you saw something like that, that makes things a little bit easier. But if you don't see that, or if it's a slope field that doesn't quite work that way, then I think the best strategy is to just pick a point. Pick something that's easy enough to work with. For example, here I see at 4, 4, I have a negative slope. I have no idea how much that's negative, and I don't really care. I just know that it's negative. So when I put 4 in for x and 4 in for y, I should get a negative number. So 4 minus 8, that would be negative. 1 plus 4, that's positive. I can get rid of that one. 1 minus 4, negative 3 times 2, that would be negative, so that'd be okay. 4 times 4 squared, that's a positive. That doesn't work. 3 times 4 squared, that's a positive. That doesn't work. Okay, so just by using that point there, I was able to eliminate these 3. I'm down to these 2 here. So maybe let's pick a different point. And you can kind of see that at like 4, 1, I now have a positive slope. So if I put 4 in for x and 1 in for y, I should get a positive slope. So if I do that here, 1 minus 8 is negative, not positive. But here, negative 3 times negative 1, that would be positive. That's the only one that survived. So as long as you're careful, you can do it that way. You might have to pick some different quadrants and stuff, but that would get us to our differential equation. Okay. For number 2, we're given a differential equation and a specific point. We're asked to figure out which of these makes this happen. So you could go down a couple of rabbit trails and try to take the derivatives of these and see which one matches, but this y is what's going to mess you up in doing that. So I think it's just best to kind of go at it the way we've been doing. Let's move the dx over, let's move the y over. You can move the whole 2y over, but I think just keeping it simple, take as little as you can. So if we go dy over y equals 2 over 2x plus 1 dx, I think that's the best strategy. We're going to now integrate dy over y equals 2 over 2x plus 1 dx. We've been integrating this one for a while. This is going to go to natural log of y equals, and then this, if you have to do a u sub, make 2x plus 1 the u, maybe do that off to the side and work your u sub stuff over here. I do notice, because I've done this for a while, that the derivative of 2x plus 1 is 2. So I have the whole derivative right up there. So I know that this is going to go to a natural log. Now, normally we'd have to put absolute value on here. They did give us this condition that x is greater than negative 1/2, which means that this part here will always be positive. So I don't need the absolute value on it for this particular one, but normally we would, right? And then I'll put a plus c. Now, let's go ahead and figure out what c equals. I'm going to put 0 in for x and e in for y. This will give me the natural log of e, which is 1. And this will give me the natural log of 0 plus 1. So natural log of 1 is 0. So that's easy enough. We get c equal to 1. Okay, so now kind of finishing it off, natural log of y equals natural log of 2x plus 1 plus 1. I'm going to raise it to the power of e. So that gives me e to the natural log of 2x plus 1 plus 1, which we're going to split into e to the natural log of 2x plus 1 times e to the first. And this right here, this e natural log will cancel. And so I'm going to get 2x plus 1 times e. And if I distribute that out, I end up with B as my answer. All right, so not too bad. A little bit of work there. And for sure, we have to be careful on this integration right there. And then moving this step here. But not too bad. All right, number 3 says, at what step does this student make a mistake in separating these out? So step 1 would be to divide the y and move the dx over, and then dividing by y would get dy over y, which is the same as 1 over y dy. So far so good. We'll put a little smiley face there. Then secondly, they would want to integrate. The integral of 1 over y is natural log of absolute value y. That's fine. Integral of x is x squared over 2 and then plus c. So far so good again. Okay. It's at this step right here that a mistake, and it's very subtle. You got to be real careful. We're going to raise both sides to power of e, which eliminates the natural log. But when you do it here, it's this whole thing is the exponent. But if you look carefully, you'll see that they only put the x squared over 2 as the exponent. The plus c is actually next to it. That's where the frowny face happens. Step 3 is where the mistake was made. Then finally, number 4 says we have a slope field shown, and we want to know for the solution that goes through here that satisfies that, what's going on as x goes to infinity. So a lot of stuff here, you can get really lost in it. The big key is to come back here. Why did they give me this? They told me the solution that goes through -2, -1. So if you go roughly -2, -1, which is about in here somewhere, let's go ahead and try to trace out what that solution would look like. So if you come this way, you can kind of see that bend, and our solution sure does look like it's going like that and leveling off. And if I were to keep that going forever and ever, it looks like it's just going to stay right along that 0 path. So what you're being asked here is, what's the limit as x goes to infinity? As x gets bigger and bigger and bigger, what's happening to your function? And what's happening is it's staying close to 0. So the limit of this function would be 0, because that's what it looks like as it goes forever and ever in that direction.